Welcome, infrastructure admins. Let's dive right into a highly focused, methodical exam prep explainer for the NCP-MCI 7.5 certification. Specifically, we're tackling Objective 9.1, and the title of our deep dive today is exactly this: NCP-MCI 7.5 9.1, What Nutanix Move Is. We're going to cover everything you need to know about this tool for your baseline AOS 7.5, AHV 11.0, and PC.75 exam. So grab your notepads because we are jumping straight into the technical weeds. You know, Objective 9.1 is kind of notorious for tricky edge cases, but by the end of this explainer, you're going to have it absolutely mastered. Here's our agenda for today. 1. Why Nutanix Move matters. 2. Move architecture and walkthrough. 3. Common exam traps. And 4. Key facts to memorize.
Section 1. Why Nutanix Move matters.
All right, commit this foundational definition to memory right now. Nutanix Move is your primary cross-hypervisor mobility solution. It's specifically designed to migrate virtual machines, or VMs, and files across completely different environments with minimal downtime. Notice those keywords there? Cross-hypervisor and minimal downtime. The exam will definitely test your understanding of these core capabilities. It's also super important to understand why minimal downtime is the gold standard here. We aren't just talking about basic offline cloning where a workload sits entirely disconnected for hours, right? The exam clearly distinguishes between simply cloning a machine and true orchestrated live migration where that cutover window is aggressively minimized.
So the underlying why here is basically pain reduction. Look, if you've been an infrastructure admin for a while, you already know traditional migrations usually mean extended downtime. It means staring at loading bars at 2 a.m. on a Saturday, manually translating incredibly complex networking and storage configurations just to get a machine to boot up on a new hypervisor. Well, Move exists to save you from that weekend work. It literally handles the heavy lifting of translating those configurations between completely different hypervisors, bringing streamlined on-prem-to-cloud flexibility right to your operations. It does the hard, manual mapping work for you. Game changer, right?
Okay, so what exactly can you move, and where can you actually move it to? These are your supported sources and targets. For sources, you're looking at VMware ESXi, Microsoft Hyper-V, AWS EC2, Microsoft Azure Cloud, and Nutanix AHV. But take a really close look at the targets. Whether you're migrating away from a legacy on-prem ESXi cluster or maybe pulling a workload out of a public cloud like AWS, the targets are typically the Acropolis hypervisor, widely known as AHV, or Nutanix cloud clusters, known as NC2, as well as ESXi running on Nutanix hardware. Understanding this matrix is absolutely critical, guys, because scenario-based exam questions will test your knowledge of what migration paths are actually valid.
Section 2. Move architecture and walkthrough.
Take a moment to just absorb this architectural diagram. Notice the Move management server sitting right there in the middle, orchestrating communication between the source and target environments. You can see the distinct data pipes flowing from your source environments, whether that's ESXi, Hyper-V, or AWS, running through source agents and disk readers straight over to the disk writer and target agent on the right side of the architecture. Understanding that these are interconnected, distinct components orchestrating the flow of data is absolutely crucial for the exam. It's not just a single monolithic pipe, it's a really carefully coordinated system. Now, because of all those moving parts we just looked at, the exam is going to want you to know that Move is officially defined as a distributed application. So why does the exam care so much about this specific terminology? Well, it's because it proves Move is resilient and highly scalable, rather than just some localized, fragile batch script running on a single host. It's a robust application utilizing multiple internal services, specifically the disk reader, disk writer, and management server, all working dynamically together for reading data, writing data, and seamlessly coordinating the entire migration lifecycle.
To truly grasp this architecture, abstract concepts just aren't enough, are they? Like, how does Move handle an entirely agentless ESXi environment versus a deeply integrated Hyper-V setup? Well, let's dive into 3 concrete examples of how Move actually migrates data in the real world, starting with a classic VMware environment. In our first example, imagine you're migrating VMs from legacy VMware ESXi to the Acropolis operating system, or AOS. Notice the flow here. Move orchestrates the process through its management server and communicates directly with Prism, specifically Prism Element, which is the AOS management plane. It does this through the management server and the source agent. The absolute key takeaway for your exam: this process is essentially completely agentless on the VMware host side. It simply leverages native management interfaces to get the job done.
So lock the word agentless right into your brain for any ESXi scenarios.
Let's move on to our second example and see how this builds. When migrating from Microsoft Hyper-V to AOS, the architecture changes significantly. For Hyper-V, you absolutely must deploy a dedicated Nutanix Move agent service directly onto the source Hyper-V host. Why the big difference? It actually comes down to how Microsoft's Volume Shadow Copy Service, or VSS, and the underlying Hyper-V host architecture handle snapshotting. Unlike vCenter, which gives you a centralized API for this, Hyper-V requires this local agent to work directly with the host to take accurate snapshots, collect source inventory, and securely facilitate the transfer of data from the source to the target.
So the really crucial point here is understanding this architectural difference. VMware integrations communicate directly with native management interfaces using standard APIs. Hyper-V, on the other hand, strictly requires that local software agent footprint to execute snapshots and inventory collection locally. If a scenario question asks about preparing a Hyper-V host for migration, deploying that agent is always your very first step. VMware is agentless. Hyper-V requires a local agent.
For our third example, let's look at public cloud migrations, specifically pulling a workload from Azure Cloud into Nutanix HV. Here, Move leverages native cloud APIs, specifically the Azure Page Blob APIs, to establish the connection. It authenticates securely using Azure Active Directory in the Graph service, and when it comes to the actual data transfer of those managed disks, it uses a Shared Access Signature, or SAS URI. The exam often tests whether data in transit from the public cloud is actually secure. The answer is yes, absolutely. It uses strict native API authentication and secure URIs, completely avoiding the need for local host agents in the cloud.
Now, regardless of your source, every single migration ends with the cutover. The exam expects you to know these 3 rules, okay? First, a service disruption is completely normal and expected during this final phase. Do not fall for trap answers that promise 0 downtime. It is minimal downtime. Second, best practice dictates you should perform this cutover within 1 week of your initial data seeding to avoid excessive delta syncing. And third, a neat little technical quirk to remember, the cutover process increments in absolute numbers. Why? Because it tracks the actual remaining bytes or files left to sync, not just some generic estimated percentage bar.
Section 3. Common exam traps.
This is perhaps the most common scenario question you'll face. Where exactly should the Nutanix Move appliance be deployed? You might think it always goes on the source, or maybe always in the cloud, but you need to know the strict default rule and its 2 very specific exceptions. Let's look at the answer.
By default, as a standard best practice, the Move appliance must always be deployed on the target cluster, the destination AHV or NC2 environment, unless you hit one of 2 exceptions. If the latency between your source and target is strictly greater than 200 milliseconds, or if your source and target are across distinct geographic locations, only then do you deploy Move on the source cluster. Let me repeat that because it's a big one. You deploy on the target unless latency exceeds 200 milliseconds. For example, if you're migrating from a legacy data center in New York to a brand new target cluster in London, where does the appliance go? The source. Memorize that 200 millisecond threshold. It'll save you points for sure.
Okay, here's another incredibly tricky distractor on the exam involving Virtual Trusted Platform Modules, or VTPMs. Move fully supports migrating VTPM-enabled VMs from Hyper-V to AHV. However, while the configuration of the VTPM is retained at the target, meaning it stays enabled, the sensitive data that was stored inside the VTPM on the source VM is not migrated. Why? Well, for strict security and cryptographic integrity reasons. You cannot simply copy secured cryptographic keys across hypervisors. So don't let a multiple choice question trick you into thinking the secured data moves with the configuration. It just doesn't.
Section 4, Key Facts to Memorize. First, let's review the core concepts. Remember, Move is officially a distributed application, not a monolithic script. Its primary job is cross-hypervisor mobility with minimal downtime. Now, look closely at that third bullet. This is classic exam trivia right here. The default internal network for Move is 172.17.0.0/16, and the specific IP assigned to the Docker 0 bridge is 172.17.0.1. Actually, say those numbers out loud a few times to get them stuck in your head. Finally, never forget that a brief service disruption is completely expected during that final cutover phase.
Next up, let's lock in these architectural rules. I'm going to summarize these quickly so they really stick. Default deployment is always the target cluster. The exception is the source cluster, but strictly only if latency is over 200 milliseconds or you're crossing geographic boundaries. Remember that Hyper-V is completely unique because it requires that local agent installed directly on the host, whereas cloud migrations like AWS and Azure use native cloud APIs, like Azure PageBlob or EBS Direct APIs, remaining entirely agentless.
As you wrap up your preparation for the certification, I want to leave you with this to ponder. Given a complex legacy environment that spans both ESXi and Hyper-V, how will you dynamically architect your Move deployment to guarantee that minimal downtime while expertly avoiding that 200 millisecond latency trap across different geographic sites? It's like a giant puzzle, right? But if you can master that scenario, you will absolutely master Objective 9.1. Good luck on the exam, you're going to crush it.